Welcome to Study Loop.
So in this question, we have a radar system attempting to detect a stealth aircraft. And first part, they want to know the intensity of the beam when the beam reaches their aircraft location. The aircraft reflects the radar waves as thought it has a cross-sectional area of 0.22 meters. So the intensity of the beam is related to the power divided by the area of the where beam is spread, so it's a sphere. And this is the upper hemisphere of the sphere. So we can substitute values here, and we get 180 times 10 to the 3 watts divided by 2 pi 90 times 10 to the 3. This is the distance of the aircraft square. Everything is in meters, so this gives us 3.5 times 10 to the minus 6 volts per meter square. They want to know for part B what is the power of the aircraft reflection, and we have to assume that the beam is reflected uniformly over a hemisphere back to the radar side. So the power refraction is the intensity times the area of the reflection. So this is 3.5 times 10 to the minus 6 times the area that we saw, it was 0.22 meters square. So this gives us 7.8 times 10 to the minus 7 watts. For part C, they want to know back at the radar site, what is the intensity and the maximum value of the electric field vector and the RMS value of the magnetic field. So let's do this. The intensity is again the intensity given by this power now, because we are back. So intensity is P, so this is supposed to be P. I don't know why. All right, R. So PR divided by 2 pi R squared. This is the same. So this is 7.8 times 10 to the minus 7 divided by 2 pi 90 times 10 to the 3 square. This is 1.5 times 10 to the minus 17 watt per meter. You see that the intensity drops dramatically because the intensity is of the reflective part only. Now they want to know the electromagnetic field, so we can find this from the intensity. So the electromagnetic amplitude, amplitude is square root of 2c mu 0, the intensity. So this is square root of 2 times 3 times 10 to the 8, 4 pi 10 to the minus 7 times 1.5 10 to the minus 17. This is the power. This is the square root here. And this gives us 1.1 times 10 to the minus 7 volts per meter. And the RMS value for the magnetic field is just, so for part E, BRMS is related to RMS value of the electric field divided by C. And the RMS value for the amplitude is just divided by square root, so EM divided by square root of 2 divided by C. And this is 1.1 times 10 to the minus 7 divided by square root of 3 times 10 to the 8. And we get 2.5 times 10 to the minus 16 Tesla.